Inverse trigonometric functions. Last year we have studied trigonometric functions. The inverse of a function is denoted by F inverse. It exists if function f is 1 1 and onto. Then what is 1 1 and onto functions? A function f from set x to set y is called 1 1 and also we can call this as injective function if images of distinct elements of first set, that is x, are distinct. A function f from x to y is called onto function if every element of second set y is the image of some element of x. That is, for every element y belongs to set y, there exists some element x in first set such that y is equal to f of x. As we know, trigonometric functions are not 1 1 and onto for all the domains and range. Therefore, we can restrict their domain and range so that the inverse of the trigonometric functions exists. We have studied trigonometric functions. These functions are defined as follows. Functions domain and range. As we know, sine function is defined for all real numbers. So, domain of sine function is set of real numbers. And outcome of sine functions lies between -1 and 1, including -1 and 1. Therefore, range of sine function is closed interval from -1 to 1. Cosine function also defined for all real numbers. Therefore, domain is set of real numbers, that is R. And what about range? Again, cos function values outcome lies between -1 and 1, including -1 and 1. So, range is closed interval -1 to 1. Third one, tan. Tan is nothing but as a sine by cos. Cos should not be equal to 0. As we know, cos is 0 for odd multiples of pi by 2. Therefore, domain of tan function is set of real numbers minus set of all x such that x is equal to 2n plus 1 pi by 2. What is n? N belongs to z. That is a set of integers. And outcome we are going to get real numbers. Cot is cos by sine. Sine should not be 0. Sine function is 0 for multiples of pi. Therefore, domain of cot function is set of all real numbers minus set of all x such that x is equal to n pi, n belongs to z, and range is set of real numbers. Sec is nothing but as a 1 by cos. Cos should not be 0. Therefore, domain of this function is set of all real numbers minus set of all x such that x is equal to 2n plus 1 pi by 2 comma n belongs to z. Since sec pi is equal to minus 1, sec 0 is equal to 1, sec pi by 3 is equal to 2. So, sec values are greater than or equal to 1 and less than or equal to minus 1. So, we can remove the real numbers from minus 1 to 1 from set of real numbers. Therefore, range of this function is r minus open interval minus 1 to 1. Next one is cosec is nothing but as a 1 by sine. Sine should not be 0. Therefore, domain is set of all real numbers minus set of all x such that x is equal to n pi, n belongs to z. Here cosec pi by 2 is equal to 1. Cosec minus pi by 2 is equal to minus 1 and cosec pi by 6 is equal to 2. So, here also values of cosec function are greater than or equal to 1 and less than or equal to minus 1. Therefore, range is r minus open interval minus 1 to 1. Since domain of sine function is set of real numbers and its range is closed interval minus 1 to 1, therefore, if we restrict sine function for the domain closed interval minus pi by 2 to pi by 2, then function is 1 1 and on 2 and its range is closed interval minus 1 to 1. Not only sine function is 1 1 and onto for the closed interval minus pi by 2 to pi by 2, but it is also 1 1 and onto for the intervals minus 3 pi by 2 to minus pi by 2. Range is closed interval minus 1 to 1. Pi by 2 to 3 pi by 2, and its range is closed interval minus 1 to 1, and so on. The inverse of sine function is denoted by sine inverse. Sine inverse is a function whose domain is closed interval minus 1 to 1. From this, what we can understand? Range of sine function is going to become a domain of a sine inverse function. And range is any of the intervals closed interval minus 3 pi by 2 to minus pi by 2, minus pi by 2 to pi by 2, closed interval pi by 2 to 3 pi by 2, and so on. Note number 1. Sine inverse should not be confused with the inverse of sin x. In fact, inverse of sin x is equal to 1 by sin x, and similarly for other trigonometric functions. Second one, whenever no branch of an inverse trigonometric function is mentioned, we mean the principal value branch of that function. Third one, the value of inverse trigonometric functions which lies in the range of principal branch is called the principal value of that inverse trigonometric functions.